Welcome to The Real Life Buyer. Whether you are buying for yourself or your business, here you will find tips, techniques and knowledge to support your journey to buying smart. Interviewing business owners and technical experts to give you information and guidance before parting with your money. Save money, time and get what you want when you want it. Now introducing The Real Life Buyer, Dave Barr.
Hello and welcome to The Real Life Buyer. In this episode, I'm very pleased to introduce you to John Loades, Director of Hazelind Consultants Limited. John is a fully qualified and extremely knowledgeable structural surveyor with whom I've had the pleasure to work with and learn the value of his expertise on both a personal and business perspective over the past 10 years. So whether you're looking to resolve an existing building concern, develop your domestic or commercial property, the engagement of a competent and knowledgeable structural surveyor is a must-have service. So without further ado, I welcome John to the show. Hi, John.
Good afternoon, Dave.
How are you doing? You all well?
Yes, very well, thank you.
I understand you're very busy at the moment.
Yes, very much so. It seems to be that all through the pandemic, it's such like the construction and planning and detailing of construction projects has taken off quite considerably. Seems to be on the back of people's minds, gone to the front of it quite quickly. It's something that everyone can get on with. So being very busy all the way through. Thank you.
Yeah, it's much better that way than the other, that's for sure. So Tom, perhaps you could spend just a few minutes informing the listeners about yourself, your extensive breadth and depth of experience, and your company.
Yes, Dave. The current company is quite a new company because I wanted to take a bit of a step back from the very busy world of construction, having spent the last nearly 30 years managing and developing a larger company. So I'm making it a bit more personal now. As I say, I've got over 35 years experience now, and it's right the way from university, changing from maths to civil engineering degree. It's been very varied since then. Managed to get fully qualified after degree level. Worked for a company along the south coast for about 9 years. Taught me the very basics, and then it's just gone on from there. So I set up my own company in 1994 and developed it from that point onwards, doing just about anything you can think of, from civil and structural engineering, from commercial buildings to domestic, alterations, new build, from the quite simple and straightforward, creating openings through to open up someone's kitchen into the dining room, or looking at the odd little crack that might be causing someone a bit of an issue, up to 200 house developments, estates with all the drains, highways, foundations, the houses, to some nice bespoke houses, incredibly large and complex, and even to current day, they might cost a good few £1 million to actually build, with the basement swimming pools and TV cinemas, the sort of thing that you see that's very popular. So yes, it's ever since those days changing from maths to civil engineering, when my roommate at university was trying to build the balsa wood bridge in the room that we were sharing, it swapped me over almost straight away to looking more from maths-based things to engineering. So quite a long time now, even though I'm not that old yet. But it's yes, so about 35 years now, and chartered since 1995, so 25 years of that as well. So yes.
Okay. What out of interest, obviously there's a huge range of projects and things you get to work on. Are there any specific ones that you particularly enjoy more than others?
It can vary from time to time. I do like, from the design side, I really like the large houses, because there's normally some very big open spaces with structures that are required to be very slender, So it's always difficult to try and get the stability and the robustness built in to within the clients and architects' sort of idea of what they want to see, and that is always a really good challenge. I really enjoy using 3D modeling, finite element analysis to achieve those sort of goals, because you can really hone in on the accuracies and the integration of bits of structure, rather than considering them separately. So you can get a lot more efficiency out of structures, which helps to get the sizes down and such like. And then another day I will be looking at a historic building or barn or something that's either got structural movement issues, or someone's looking to convert that the agriculture building or a barn or stables into a holiday let or a bit of ancillary accommodation, home office or something like that. And when you're trying to work your way through lots of 300, 400, 500-year-old bits of timber in there, trying to work out what's going on, why is it leaning over one side, what's the best to do to keep that character but keep it stable now. Yes, it's a very, very big range in there. And I also like the geometry and headaches that come with looking at a whole road and drainage layout, because it always seems to be that the developers that I work with a lot have some quite challenging sites, usually quite sloping, which always makes that sort of thing difficult. So, anything that's a challenge on that, or can get you out and about in the outdoors and looking at historic buildings. It's very interesting. Yeah,
sounds great fun, actually. Just thinking about that though, because of the huge range of different challenges perhaps you'll meet, one needs to be very careful when a person chooses a structural engineer. So to understand what qualification and experience should myself or anybody else looking to take on your services or another engineer's services, what should they be looking for?
Ideally, you want to be looking for a chartered structural engineer for anything that's to do with structural engineering. Many structural engineers can also cover civil engineering, which I believe we'll have a talk about the differences of that later on. But there are quite a few and far between chartered engineers. But there are quite a lot of quite well experienced technicians or people have worked in the industry for quite a long time. But I would always recommend trying to start off to find a chartered structural engineer for these type of issues, because the qualification process is so demanding and arduous. It's very akin to getting qualified as a lawyer or a doctor and an architect. It's 7 or 8 years in the making of degree, plus professional training, plus some very stringent exams to pass, numerical and verbal interview type and project presentation. So it's a very, very good test of the experience and knowledge that you've got, and then to look at the experience on the carrying on from them. And it's only really then talking to different engineers to see how you can get on with them. That sort of thing to start off with is always good to approach people that you might know have already used the services of a structural engineer, particularly perhaps if you're looking at a project of your own, you might already have an architect on board, and they will have a good working knowledge of engineers around that they like to work with and that they can recommend as well. So it's having that good working relationship with the architect as well as directly with the client. So it's a triangular team.
Yeah, it's an interesting point, that, because that's one of the things I think can be a little bit confusing is the different roles people play. So you have the structural engineers yourself, you'll have an architect, you'll have a builders and such. What are the differences between the different roles and how do they interface on a project?
Well, very often taking a domestic project, say a large extension, as a sort of starting point example. Most likely, an owner will have some idea of what they want in the first place, either from what they've seen in magazines or their friends have got, or just of their own design aspirations. And it's normally then the services of an architect will be involved first, because they will look at the overall space requirements, the aesthetics, even down to some of the more practical things of fire escape routes, and whether the main services are going to work, whether you've got the right drainage in those areas. You can't, it's difficult to put a new bathroom somewhere that's not going to get into your mains drainage, for example. So look at the space arrangements. But I would also expect a good architect to have some knowledge of what is feasible from a structural point of view as well, as in, they're not going to try and create something 10 meters square, clear open space with your rear wall of your house being supported across the middle of it somewhere. So they've got to use a bit of experience and knowledge on that. But once they get the space designed and the clients are happy with how it's working, then the structural engineer will get involved to try and make that vision stand up. But not just stand up, it's to be what we call serviceable, as in that it doesn't move around too much and cause cracking plaster and such like. And it's also safe for things like vibrations aren't too much, so the floors don't bounce, or you get, and also durable. So there's things like protecting them from moisture with the paints and surfaces, such that the structural integrity is going to see the life of the building out. So it's a combination of all those elements. Both architect and engineer will, or should have a good idea of how the building's going to fit together from a contractor's point of view, to try and make it efficient, and not just efficient from time-wise, but efficient and economic to achieve what you want to achieve. So they'll be selecting ways of supporting structure, ways of achieving what you want the looks to be, in a way that can be built most easily and in the most economic manner. And it'll often be quite good to have contractors on board fairly early on as well, who are, because sometimes there are choices to be made. Are the preferred contractors even going to prefer doing something in timber, or they're going to prefer to be doing it in steelwork? So there's just the good working team is the real key. There are separate roles, and they do overlap a bit, and a good understanding between each other is what leads to a successful project.
Yeah. Now, you mentioned some materials there. I guess you must have quite an extensive knowledge of the different materials available and their properties, I guess, one way you could say about them. But is that something that you just have to learn over time? Is there somewhere you can go to understand more about how the material works? How do you go about selecting the right materials for the job, or is that the architect's role?
As I say, it's a whole indication of between the team. Some clients might have preferences for different types of materials, for environmental reasons or for thermal reasons. Or, for example, timber framing structure is considered more environmentally friendly if it comes from a sustainable source for the timber, compared to concrete block work, which uses quite a lot of energy to produce. But on the other hand, the block work is often made with the residual leftovers from furnaces and such like. So it's a recycling matter in there, but it still uses quite a lot of energy to produce. But then timber's difficult to keep dry during construction, and they might cause shrinkage problems there, whereas the block work is not quite the same. and it's easier to control with a bricklayer doing one element of the work compared to a timber frame company doing another part. A good example of one I've just done is doing a large barn conversion, which actually involves taking the barn down, essentially, but then building a very large basement underneath. It's about 4 times the size of the barn itself. So the basement's all gone in waterproof reinforced concrete, fine, but the barn was going to sit on quite a chunky steel frame, and then what we call like a composite concrete and steel floor deck over the top, which doesn't require any shuttering because you put the steel deck to the steel frame and pump concrete over. But it's happened that the contractor that the client has chosen would prefer to do his own shuttering and his own concrete work rather than that system. So I've just redesigned that one to do it in reinforced concrete. So that sometimes it all depends on the preferences around. I'll say the difference between timber frame and block work is quite a common one, and it really is balancing on a 50-50 preference on that. But there are other systems and materials as well which I got quite a bit of understanding of that aren't new and up and coming systems. Things like the ICF polystyrene blocks that you fill with concrete, and SIPS panels, the structural insulated panels, which are sandwiches of timber and insulation, which actually work as structural walls in panels, and metal stud work. There's just so many different materials to be considering there. It can be mind-blowing, but I think talking to the architects and the engineers is the first place to really get a good impression of the types of more traditional materials. But there's a wealth of information on the internet as well if you're looking up more in vogue types of materials. I'm always I'm getting a bit older now. I'm always a little bit wary of some of the newer materials. All have their benefits, but they do have drawbacks, usually attached with quality of workmanship to achieve the target of what you're expecting from them. They can be very successful. So a lot of the materials, more unusual materials we've been worked in is I've done one building in blocks of straw, and quite a few bits of structural glass as well, glass floors, glass walls. That's always very interesting, particularly with fire rating for those. Yeah. So you can get involved in a lot of different materials. Yeah, so experience is there. Yeah, and in your team is the real advantage there.
Yeah, and I guess you get to see the outcome of those materials at the final product, and you get some faith and understanding that they do what they say on the tin. As you say, the newer materials, you won't have that experience, and so you're very reliant on the specifications of the manufacturer.
Yeah.
I guess. Yeah.
I mean, there's some of them I don't get to see them so often when they're constructed unless they go wrong. So I'm probably tainted with the view because we only tend to get involved again when they've gone wrong.
Yeah.
And a very serious one, probably a good 5 or 6 years ago, was using the ICF system to build a whole house. So you've got your polystyrene blocks with the core in the middle that you fill with concrete. Ideally, it's supposed to be reinforced, but you can design it using fibre reinforcement. They're small, and it was GRP, glass reinforced plastic fibre reinforcement in this concrete. It's not massively structural, but you need something to hold it, to knit it together. And the contractor forgot to put the fibre in when they pumped the concrete. So they formed the whole house before anyone realised that they hadn't put the fibre in there.
My God!
So most of it was okay, but we had to design a lot of post-fixed steel plates, which were resin bonded over lintels and sort of routed out slots to put metal bars in them. So it was a very painstaking process to put that right. Yeah. So one little omission on a new product, something like that, and it can lead to a lot of hassle. So which probably leads to one element of supervision or inspections by engineers and architects during works. Very often we're not required. I can only imagine, mostly because of the budget constraints on most people's projects, that you lose contact with the projects when they're on site a lot of the time. And as I say, we probably get tainted view a little bit, because it becomes a point when there is no choice because there's something gone wrong, that you get involved with it on site.
Yeah.
It does build up the experience of dealing with problems, but can leave you a little bit short of the nicer experiences of seeing something being constructed well.
Yeah.
Yeah.
Okay. You mentioned civil engineers a little bit earlier as well. What's the difference between a civil engineer and a structural engineer?
Apart from being more polite, yeah. The civil engineer, they always said they would describe themselves as a party as they're boring, as in boring holes. But civil engineers basically deal with infrastructure. So looking at most heavy civil engineering is motorways, dual carriageways, tunnels, railway line, other services, main drains, and such like. So it would have been very heavily on civil engineering, doing the Channel Tunnel and all the motorway work that gets you there. The structural engineers would probably be on something like that, more involved with designing the bridges over the motorways. And then when you get more down into more the sort of micro level of project rather than main public infrastructure, civil engineering, from my point of view, tends to mean estate roads and estate drainage. So it's more sort of external works than heavy civil engineering, but it's still quite demanding, trying to get the geometries of the drainage and roadways to match up with the site, getting the drains to actually discharge into the point where they're going to reach, making sure it doesn't flood, making sure that all of the houses going onto an estate have appropriate means of access for disabled access, and everything's safe to use. So it's quite a lot of parameters to pull together.
Yeah.
So and then the structural engineer on someone that will design the foundations, the house structures, all the beams, joists, lintels, roof structures, and that to complement it. What can be confusing is that there aren't really any structural engineering degrees in the first place. That civil engineering tends to be the broader subject, with the structures part as a sub project, sub area, subgroup in the
sort of niching
the area of
down.
engineering. Yes.
Yeah.
So,
I see.
yeah.
Okay, so if a listener has a project in mind and there's a need for a structural engineer in that project, how would you recommend they go about searching for an appropriate engineer that would meet their needs?
So firstly is probably be talking to the rest of the team if they've got one already engaged, the architect or other family and friends that may have already used one locally. But other than that, I can thoroughly recommend a part of the Institution of Structural Engineers website, which is actually called Find an Engineer. And all of the, or most of the chartered structural engineers that are members of the Institution of Structural Engineers will have a record on there. So in effect, they're pre-vetted to be on there from a professional body. So you're not going to go too far wrong by starting on there. And I'm listed on there, and I'm probably one of the only ones within quite a radius that's listed from where I'm based. To say there are probably quite a few and far between, to be honest, outside of London and the suburbs or the main cities.
Yeah.
So that's the best way to go about it.
Okay, so let's say a person identifies an engineer, or maybe two or three, if they're really lucky, in obviously a large location, let's say if you're in the middle of London or something. But is there any warning signs that people need to be aware of if they've started to talk to an engineer? Should there be certain things to keep an eye out for, just to make sure that they are going down the right path?
It is difficult because obviously engineering speak is often difficult to follow for laypersons. So and good engineers can make things understandable to anyone, and there's one of the big skills. So how they come across is always very helpful. A big problem to look out for is things that look too cheap to be true. As with anything, you do get what you pay for, and engineering is one of the sides that, even though I do say so myself, that very often the more you pay for it, the better the service you will get, because we are professional persons with a high level of integrity. So it's and with going together with the qualifications required. But on top of those, is to not just take the cheapest quote that you might get for something. It's because it's not all about that, and it's a separate subject to talk about, really. But it's talking to the engineer. Do they make sense to you? Can you understand the sort of problems that they're trying to put over to you? Are they just raising problems for you to try and impress you, or are they, yes, going around the challenges that are there, but thinking ahead to what the solutions might be, preempting those? It's more of an attitude to problem solving as opposed to trying to just line up the problems in front of someone and standing back. And that is definitely something that can be picked up just by talking to or meeting prospective engineers on a project. As I was alluding to about the cost wise, when you look at full building life costs, spending a bit more at the beginning in the design to make sure that it is correct, it's going to be durable and serviceable, pales into absolute insignificance in relation to how much that building is going to cost to build, run, and ultimately demolish at the end of its lifespan. That it doesn't make any economic sense to scrimp at the very early stages, and that's a very big area that I like to promote.
Okay. I thought of a few common things that people may be interested in. I certainly have some experience of some of these. Let's say a person, as you mentioned earlier on, found cracks appearing in their property. So therefore they're fearing some structural movement is taking place. What would or what should they expect a structural engineer to do to investigate that? And what kind of costs would people be having to prepare themselves for?
Yeah. I mean, that's a very common problem, and I must say, in my experience, more than 9 times out of 10, it is nothing serious to worry about once it's been inspected. Nowadays, most people tend to just go straight to their insurance company. I don't really advocate necessarily doing that unless something's quite bad, for various reasons. That being that they will send out an engineer or a surveyor to look at it, but they haven't got your interests at heart from the out. So, I mean, they're reasonably good at doing this sort of thing. They know what they're looking at, but they are got the interests of the insurance company at heart. And most of the time, the cracking that you see isn't that serious anyway. So you're probably not going to get much further forward other than the insurance company saying it's not an insurable peril and it's not a serious problem. We're not going to cover it. It's something you need to deal with. A structural engineer at first, just from a walk around and visual inspection, will be able to give a very quick summary of, is it a problem? Is it a big problem, or is it just a minor problem, something that can be repaired cheaply, or is it something that's going to need some proper investigation? And from that, we call them a limited structural inspection, because it's based on just a visual inspection and not to open up anything there. And as I say, 9 times out of 10, that's as far as it goes, because the cracks might be 1 or 2 millimeters or less, or just hairline. They're just the sort of thing that would be expected of a particular building's type and age, or they can be reasonably easily repaired with a bit of mortar repair outside, or a bit of metal bar strengthening, or replastering with some steel mesh inside, something that's not going to really get much worse. And these are all things that can be quite easily provided information about to the customer, to the client, to put their mind at rest that it's nothing serious. Those sort of things, depending on how big the property is, how widespread the damage. Current day, you'd be looking at anything between about £700 and £1,500, excluding VAT, for a visual inspection and a report, a reasonably detailed report to follow it up. And from that point onwards, if the conclusion of that inspection is that further investigations and that there is something more serious to look at, then we would advise of the cost involved, at the timescales, and how it could be gone about to move it forward. And also advise whether we think it's going to be something that's covered by a person's insurance policy or not, as to whether they want to advise their insurance company. So there's just so many causes of cracking, and everyone clings immediately onto subsidence. But the opposite of subsidence is heave, and that's, to be honest, can be a bit more common than the subsidence side of things anyway. Basically, subsidence, it goes down and heave comes up. There are so many other causes of cracking in properties, from corrosion of wall ties to leaking drains, flushing away ground under foundations, to thermal movements, to vehicle damage. It's amazing how many buildings have been hit by vehicles that people didn't realise. Down to just plain wear and tear or timber decay. You get dropped lintels, soldier arches and things like that, all of which are, say, most of the time it's either just a bit of thermal movement or old age, wear and tear, and there's something in there that hasn't quite got the strength that it did have before. So say like a timber lintel or wall ties, that just allows a bit of movement in masonry, and generally they can be quite easily remedied to keep things in control and keep them looking nice.
Okay.
So, but everyone's scared of that subsidence word.
Yeah.
And it's not as common as people might think for it to occur. So.
That's good to know. I'm thinking about now those people who perhaps have a growing family and would like to stay where they are, and so they start to consider extensions, perhaps a 2-story extension. What kind of challenges would that pose, and what should the structural engineer do in that instance?
Most run-of-the-mill 2-story extensions are not that not too demanding from a structural point of view, although the common current preference to provide an open plan kitchen family room can have its challenges because of the open plan nature of the space. So you'll be looking at using combinations of, if we're looking at something like that, the larger span one, often it's got a projection at ground floor that's bigger than the first floor, if you say like. So there might be some larger than perhaps the client's expecting steel beams over, and with the open plan nature, you're very likely going to have some steel columns as well, all of which we always do our best to try and hide, unless someone's idea of the aesthetics required actually wants to see a bit of more of an industrial look. But I always advocate that with these things is for someone to always go down to try at first to do what they really want to do. As in, if they want to open up the whole back of the house and they want to have a 7 or 8 meter square open plan space, then go for it first. And then only come back if something like cost, it becomes a real issue, because there are things that can be done to massively reduce the build cost of these things. But of course, they compromise the look of it. And the particular one, for example, which we do step back quite a bit, is as I mentioned, the open planned kitchen diner family room. Is, do you really, really want it completely open plan? Because it might cost you £10,000 more to do that, as opposed to putting a 6-inch circular column in the middle of a kitchen island, which can be made to almost disappear in the visuals. But if that's in the centre, it breaks all the spans in half. As I say, it could be a massive cost saving on the actual construction. And it's the same with always one of our tricky areas to do is to try and make all the steel beams that are in the ceiling concealed, because people don't like to see downstands. So there's one area of work that takes quite a bit of experience to know what can and can't be done to do that sort of thing, because it's quite difficult construction wise, particularly when those beams are deeper than the floor thickness above. So it's that experience of knowing what can and can't be done, and what elements are going to cost a lot of money to perhaps not achieve a massive amount of difference, and being able to convey that to a client, as to say, well, you can do this for that much. It's going to cost you twice as much to do this. As I say, but I always say, go for what you really want first, because you might regret it if you step back from the word go. So my mantra is that one.
Okay. Then I understand there's a slight difference when it comes to a semi-detached property. You've mentioned the open plan trend perhaps at the moment. Is there a requirement for a party wall surveyor in the case of a semi-detached property?
It depends on the nature of the work. The party wall act is, and I do spend probably 30% of my time as a party wall surveyor as well as an engineer. And the two main, there's lots of parts of the party wall act that could come into play, but the two main areas are where works are being done to a party wall, such as building in beams or building dormers up to the fire break wall line on a party wall for a loft conversion, and removing chimney breasts and such like, where you're actually going to do some physical work onto a party wall that could affect the neighbour. So it's a protection in both ways, to know that you have the right to do that work under the proviso that you've got to make good any damage you cause. But you've also got to do the work in such a manner that you're trying not to cause damage. But then there's also a protection that for you to doing the work, give you the right to do the things that you want to do, and not being too restrictive on the works you can do. So in a semi-detached property, that's definitely one that could come up. If you're doing an open plan arrangement, you can have beams being built into a party wall. But the other part of the party wall that can come into play, and very often does, is the adjacent excavation element, which could apply to not necessarily semi-detached, but it could be an adjacent detached property as well. Because if you're doing drainage or foundation excavations, and if they're within 3 meters of your neighbour's property or any building structures, then obviously there is a risk that you could cause disturbance to those elements by excavating into the ground too close to them. So that's a whole area that we can address from a design point of view as well, to either avoid having to cause these issues with the adjoining property, or to deal with them know in the knowledge that the building owner and the person doing the project has the right to do them, and that's what they want to do. So it's then managing it through issuing the required legal notices to the adjoining owners, and then following that through, if required, to condition surveys and party wall awards, which just sets everything up correctly to protect both parties from doing that work. I'll say protect both parties because obviously people doing building works don't really want to be accused of causing damage to adjoining properties that was pre-existing. So it's a protection on both sides as well.
Yeah.
So it's a whole different area of things to, as I say, to build into knowledge of the design in the first place, to be a good practice to building close to or into adjoining properties, but then to deal with the legal side in the most efficient and cost-effective way.
Yeah.
And what a lot of people don't realise is that the Party Wall Act and surveyors acting as appointed surveyors under it, they're all have to be completely impartial. So they're protecting the properties and the act itself, and are not at the beck and call of their appointing owners on either side. So that can be difficult to when something's one area of neighbourly dispute is often around works close to and around a boundary. So it does take some experience and to deal with.
Yeah. Okay. Just one other question that just popped into my head. Those people with, should we say, a much older property, when such things as asbestos are involved, what are the implications, the ramifications of finding this material in a construction project?
It's one area. I mean, obviously, I know from a health and safety point of view, and I'm not an asbestos expert by any means, but I do know that for residential properties, the onus on the owners is not quite as high as for commercial properties. But hazardous materials in general are dealt with in two ways. Is to either come into one class like a lot of asbestos, where if you're not going to touch it, not going to disturb it, then in the main it's best concealed and left alone, because to remove it and dispose of it is difficult, costly, and obviously not particularly environmentally friendly. And sometimes it's actually better leaving it where it is. But then a lot of people don't want to, even the knowledge that it's there, even if it's not affecting them, would prefer to have it removed anyway. But asbestos, as an example, is something that needs to be dealt with by a specialist contractor who will remove it without causing any health issues to themselves, to any occupants in the property then or in the future, and make sure that it's disposed of safely to an appropriate license tip, because what you don't want to be doing on that is having someone remove it and then just fly tipping hazardous materials, or concealing it in black bin bags and taking it to the residential tip, which could adversely affect people, all sorts of people in the future in different ways. So it's a whole area of working is dealing with hazardous substances, and of course we're getting more and more aware of some materials that have been used quite regularly, even up to the 1980s, and even beyond. With fire, not necessarily hazardous ones, but perhaps materials that are not as fire resistant as people thought they were. The typical things in houses, though, that people don't realise, that Artex has got generally got asbestos content, as well as vinyl floor tiles, particularly if they're from the 60s and 70s. Even Artex ceilings up to the 80s could very well have asbestos contained within the Artex ceiling. But something like that is normally easier just to overboard it and leave it in place rather than scrape it off. That's probably about the worst thing you can try and do. So yes, it's a whole area of work that needs some special consideration.
I thought that'd be the case. Something I just started to hear about is building information modeling. I believe you're becoming very aware of this now. It's
Well,
quite
I
an
have been,
interesting area.
yeah, it's something that I've been very interested in and championing really for probably about the last 10 years. Um, and it's something I've tried to push forward with my previous company, and particularly on the focusing very much on the within the office onto the 3D modeling side of things, where the idea being is that everything you design and detail is contained within something that has information attached to it, intelligent information, which can be passed from early design into the detailing, onto a contractor who can then add their own information embedded into that system, that also provides that information ready for users. So it's automatically available, and down to where that information is available for demolition as well. To give you some sort of example how it works, probably comes from one of the Autodesk sort of adverts originally. The idea is that right from the word go, you can sketch in a 3D model environment. Imagine that goes through the design of a hospital, they use as an example, where then you've got architects, engineers, mechanical, electrical, and ventilation people all working in a model that's in a 3D space shared, where you are ultimately, the model is live, so that if someone's moving or changing things around, you see, if someone moves a wall or a column, it's going to come through to all of the design party. It will do clash detection on things, and you can save an awful lot of money during construction because you can make sure everything fits in the first place, rather than trying to put ventilation ducting through concrete floors and beams that just appear from nowhere on site that people didn't realise. And then when the contractor builds it, he can adjust, keep the model up to date if they do make any little changes. And one example they give you is a maintenance person walking around the hospital with an iPad that can literally knows where that is anywhere in the building. And it can almost just hold it up and use it like an X-ray. It looks like an X-ray because it knows what's in the wall, what's in the ceiling, what's there, because it's been recorded. So from a maintenance point of view, it's just amazing on that. So it's a very clever and way forward of making sure everything is integrated. The clash detection and all the information is attached. You don't just draw a line on a drawing that's just a line. It might represent a beam, but it's just a line. You will model a beam in there, and it knows how long it is, which beam size it is, what the surface area is, where all the holes are in there. And once you've built up a whole model, it can, a quantity surveyor can be looking at withdrawing from that all the information about every single element in there and all of the quantities, for economizing that structure. So you know exactly how much is every material is in there, down to how many millimeters of architrave you've got around doors. So it's a very quickly expanding and very interesting subject looking at it from that way. But it is a management protocol that's much bigger than that.
Right.
But it is that's the core of it. It's having a whole building information model, which is embedded information in there for everything. So it's like a big bubble for your construction project where everything is known about anything, and you can interrogate it and change it, and review all the way through. So I've been spending this summer really getting to grips with some of the software, the newest elements of software that will allow that area of modelling and my personal expertise in that modelling really take off, I think, now, with the likes of Revit and Civils 3D, and flow, causeway flow, drainage. You can integrate all of them together, and you can build up a whole construction site in 3 dimensions with all the information of everything integrated together. So it's no, I like and enjoy playing with that sort of information.
Yeah, you can see it's going to be hugely valuable for, let's say, a property after 5 or 10 years. If they need to have any works done, you can, I guess, fire up the software, and anybody who's coming in to look at the work could then see exactly what's happened, where things are, and as you say, really drill down into the structure very
Yes.
quickly.
Yeah.
Yeah,
Providing, of course, that the contractors have updated it when they
yeah,
built, and it which is another area completely with construction design, health and safety management.
yeah,
Is that this information is meant to be kept up to date right to the point of completion,
yeah,
to then be provided to the building owner and user at the end of the day, exactly for that purpose, for future maintenance and ultimately demolition, so that you know what's in there to take it apart again.
okay.
Be that many hundreds of years away.
Yeah, yeah. Okay, I'm
Yeah.
just recognizing the time is marching on, so I'll ask you
Yeah.
one final question.
Okay.
And just to give people some expectations, if they're engaging services of a structural engineer, what kind of rates and payment terms should they be prepared for?
Well, it can vary a bit, but it's a fairly small window. It's I will say that we generally try and provide a fully broken down, itemised quote for works once understand the scope of said work, and try and fix that price as much as possible, because that really helps to avoid any unforeseens. But you could be looking at hourly rates of generally between sort of a 90 to 150 pounds an hour work. So nicely cheaper than most legal professionals, but akin with most construction sort of
Yeah,
professional sort of rates. And payment terms, obviously as quickly as possible. Is most commercial clients work on sort of 30-day
yeah,
turnaround, so we need to work on that, and that's fine. And domestic clients anywhere between sort of 7 and 14 days usually from
yeah,
actually completing the stages of work.
yeah.
One thing we don't tend to do as a profession is to ask for any payments in advance of doing any work. Uh, Unlike some contractors scrupulously might ask for or such like, but it's pretty much always in arrears for work done. So they've always got proven amounts of work that's completed and then invoiced for at that stage.
Great.
Yeah.
I think that's very useful for people to have a rough idea of what they should be thinking about. So if anybody wanted to make contact with you and your company, Hazelind, how would they go about that? What's the best methods of getting in contact with you?
Ultimately the first one is our website, which is hazelind.uk. Which is fairly new now, so that's all up and running. There's also a couple of blog pages on there, which make some interesting reading. We've got a quite an extensive LinkedIn page just under Hazelind as well, which can be found. Other than that, any sort of inquiries could be submitted under hazelind.com. So projects@hazelind.com email address. So that's best way to really try and get in contact.
Excellent. That's really good. Well, thanks very much for that, John. I could spend quite a long time talking to you about all sorts of different scenarios. Perhaps we can do a podcast another time on some of the more popular subjects. But
Yes, that would be an interesting thing to do. We look forward to it.
yeah,
Thank
it'd
you,
be
Doug.
fantastic. So all I can say now is thank you very much for your time. I've really enjoyed our discussions. I hope it's given the listeners quite a few things to think about, and hopefully some useful knowledge and tips. So once again, thank you very much, John. I really do appreciate your time, and hope you have a great day, and hope to see you soon.
Yeah, thank you, Dave. I'll see you soon too. Thank you.
Thanks, John. Take care. Bye.
Thank you for listening to this podcast. Please subscribe and leave a positive review if you can spare a minute or two. If you would like to contact me, my email address is david@thereallifebuyer.co.uk, or find me at Real Life Buyer on Facebook, Instagram and Twitter, where you're welcome to direct message me. I look forward to you joining me on future episodes. Take care and remember, save money and buy smart.